Hello ladies and gentlemen, we're going to do some more nonlinear inequalities. Again, this is the last thing that is on your test, so make sure you practice these problems. We're going to go through these by first. Every one of these problems you're going to want to set them equal or unequal to 0. So for this problem I'm going to subtract 2x on both sides. Okay, like we're solving any other quadratic. So you would subtract 2x, now we've got a quadratic on the left. Now we need to factor this, so what multiplies to negative 3 and adds to negative 2? It would be negative 3x and positive 1x. Then I'll do grouping, x minus 3 plus 1, x minus 3, and I end up with x plus 1 and x minus 3. And I want to know where this is less than 0. So when you're doing these problems, you want to find like things that are important along the x-axis. So these are zeros. At negative 1 and at positive 3 we have zeros. And what I'm going to do is I'm going to draw a number line, and I'm going to put negative 1 and positive 3 on here. These kind of represent the x-axis. We want to know where it's less than 0. So what we're going to do is make a sign chart, but first let's think about these points. If you plug negative 1 in, you will get 0, and 0 is not less than 0. So we're going to put an open circle here and an open circle there. Same reason for for 3. Neither of them work because 0 is not less than 0, it's less than or equal to 0. Now we'll do our sign chart. So for our sign chart, I'm going to test numbers to the left of negative 1, so I'll do like negative 10. And I'm going to plug them in right here, and I'm going to see what happens. If you plug in negative 10, right here, negative 10 plus 1 is a negative 9. That's a negative number. If you plug in negative 10 right here, negative 10 minus 3, that's also a negative number. So if you have a negative times a negative, you're going to end up with a positive number. Let's pick something in this interval. I'll pick 0 if I can. 0. 0 plus 1 is positive, 0 minus 3 is negative, and when you multiply those factors together, you will get a negative. Now we'll pick something that's bigger than 3, 10. 10 plus 1, positive. 10 minus 3, positive. Their product, positive. So what this is telling you is that your quadratic is hitting the x-axis at negative 1 and 3. It's going below the x-axis, that's why it's negative, and it's going above the x-axis. It's a parabola that opens up. You can kind of visualize it. What I'm going to do now is write my answer in interval notation, and I want where it's less than 0, so I want the negatives. I want this interval right here. So the way you say that is from negative 1 to 3, and since they're open circles, we use parentheses. And that is an interval, that's not an ordered pair. That's from negative 1 to 3 using interval notation. That's saying all the points between negative 1 and positive 3 will be less than 0 if you plug them into that parabola. Let's do another one. Okay, let's do the fraction one. So for the fractions, you're going to kind of do the same thing, but for this one, you're going to have, your critical points are slightly different. So you're going to set the numerator equal to 0. When does 3x equal 0? And you're also going to set the denominator equal to 0. And that's because here you have an asymptote, a vertical asymptote. So we got to be really careful here. X can definitely not be 3. Because if x equals 3, you have 0 in the denominator. So that's big. No, you can't do that. So we're going to have to pay attention to that. That's going to be a hole in our solution set. Here, the numerator equals 0 at 0. So I'm going to put dots at 0 and 3. And remember, it definitely cannot be 3, because if it's 3, you have 3 minus 3. Oh, that's not good. Can it be 0? So if you plug in 0, is 0 divided by anything greater than 0? No, it'd be 0 is greater than 0 again. So these are both open circles in this problem. But this can be kind of tricky. And our sign chart's going to look slightly different because it's a quotient instead of a product. So when we think of the signs of these, we're going to have to think of the numerator divided by instead of two factors being multiplied. So first pick a negative number. If you plug a negative number into the top, you'll get a negative, and a negative number minus 3, you will also get a negative. So we'll have a negative divided by a negative, which will be a positive. If you pick something like 1, 3 times 1, that's positive in the top, and 1 minus 3 is negative in the bottom. So if you have a positive divided by a negative, that's going to be negative. If you pick something bigger than 3, like 10, 3 times 10, that's positive. 10 minus 3, that's positive, so their product will be positive. Now we're asked to find where this is greater than 0, so that's the positives. So I'm going to find the intervals in which this is positive. The intervals which this is positive are here and there. Oop. shaded the one above, but just so you're, while I'm thinking about it, we should shade that region there. Okay. Now, to write this in interval notation, you have to think you went forever to the left, so that's negative infinity, and that's always parentheses. You can never count to infinity. And then you got to pick up your pencil at 0. Union, we can do the same thing over here. So positive 3 to positive infinity. And that is our solution set. Any of those points will give you positive numbers for your fraction. So let's keep going. We have another problem here. This one's set up as a quadratic. So let's just go ahead and factor it. So what multiplies to negative 12 and adds to negative 11? I think that's negative 12 and 1. So I'll split the middle. And that means my factors are 3x plus 1 and x minus 4. And I want to know where this is greater than 0. So first I find my zeros at negative 1/3 and positive 4. If you're not sure how I'm getting that, write yourself a little mini equation. When does this factor equal 0? When you subtract 1 and then divide by 3, you get negative 1/3. Do that a few times, you'll be able to do it in your head. It's a two-step equation. So let's draw a number line, and we're going to put our points of interest at negative 1/3 and positive 4 on the number line. Since it's strictly greater than, plugging these in gets you 0, and again, 0 is not greater than 0, so these are both open circles. And now we're going to make our sign chart. So pick a number that's really negative, negative 10. I just like to do them because they're easy. That'll be negative 30, that's going to be negative. And negative 10 minus 4 is also negative, so that's positive. Pick a number in the middle, 0, 0 plus 1, positive, 0 minus 4, negative, their product is negative. And then a big number, 10, 31, 6, both positive, their product is positive. I'm asked to find where it is greater than 0, so again I want the intervals where it is positive, that is the outside here. So I'm going to shade that, and then I'm going to write my solution set in interval notation, negative infinity to negative 1/3, again parentheses everywhere. 4 to infinity. Look at that infinity. That's a good infinity. One more fraction problem. So we'll pretty much do the same thing. Set the numerator equal to 0 and set the denominator equal to 0, and these will be our points of interest. So 2x equals 6. That means one of them is at 3 and the other one is at negative 5. And this one's really important. X can definitely not equal negative 5. Now if you do 3, you're going to get 0 in the top, and 0 is going to be also an open circle. So we have negative 5 and positive 3. These are both open circles. Now we're going to do our sign chart. So let's see, negative something. Let's do negative 10. That'd be negative 20 minus 6. So that's negative. Oop, we're dividing now. And negative 10 plus 5 is also negative. So their product, or their quotient in this problem, is positive. In the middle we got 0. 0 minus 6 is negative. 0 plus 5 is positive. That means it'll be negative. Big number. 20 minus 6 is positive. 10 plus 5 positive. They're positive. Okay. So what do we want? We want the interval that is negative, so we will shade in the middle, and then in interval notation we're going from negative 5 to positive 3, and those are both in parentheses. That's not an order pair, that's interval notation. I think we got maybe some graphing problems. Yeah, okay. So let's do the same thing. The function f is pictured. No, it's not. I guess we got to draw it. Okay. Hang on a second. What's going on? Magic! Look! The graph's there now. I hit pause. That's cool. So I went ahead and graphed these. Now you would use Desmos to graph them, but what we need to do is verify what's going on algebraically to make sure that our graph matches up. So I'm still going to factor. I'm going to find numbers that multiply to negative 15 and add to 14. So that would be 15 and negative 1. And then I've got GCF of 5x, so x plus 3 minus 1, x plus 3 because we factored out the negative. And then we have 5x minus 1 and x plus 3. We want to know where this is greater than 0. So our zeros should be at add 1 divided by 5, 1/5 or negative 3. So you can see I have my graph here. Point 2 is 2/10, 2/10 is 1/5. So I'm verifying that my zeros are correct. If I didn't give you the Desmos version, you would have to then, sketch it using what you've got. But here I've got the picture. Cool. You'll normally have the picture. So what are we asked to do now? We want to know where it's positive, so we don't need to make a sign chart. It's above the x-axis, right there and right there. Here it's negative. And since it's strictly greater than, this is kind of different weird notation, but these are going to be open circles. You kind of imagine this as being your sign chart. So the intervals that I care about are from negative infinity to negative 3 union 1/5 to infinity. It's important you realize that when we say infinity, we're talking about x going to the right. This thing is going to the right forever. It is also going up, but we're talking about the x's. Interval notation is referencing the domain, the x's. Let's try another one. I've got my graph here. I'm going to set my numerator equal to 0, and I'm going to set my denominator equal to 0. X minus 3 equals 0. So I have things happening at -1 and at +3. This is a 0. Yep, we got it. What's happening at 3? Oh, that is a vertical asymptote. Okay, so it's still something we got to pay attention to, but it's not a 0. So what am I asked to find? Where is this greater than or equal to 0? Now you'll notice this thing is above the x-axis, and since it doesn't hit the x-axis, we didn't find a 0, so it doesn't hit the x-axis. It never gets there. This whole interval is above the x-axis, and then this, once you get through the x-intercept, is also above the x-axis. So you have this interval and you have this interval that we need to describe. So I'll leave those there. Let's say negative infinity to -1, and since it's greater than or equal to, we can use a bracket there, union this whole thing from 3 to infinity. But it's important you realize that you have to make sure you go past the asymptote, because to the left of 3 it is negative. So it's kind of like you get to 3, you got to pick up your pencil, and then you can say, well, after that it's going to be positive again. But we have to get through that asymptote before we can say anything about it. Okay, I think we got one more. Yeah, so this is a cannonball problem. I give you the equation, and then it says, where is it above 704 feet? So algebraically, we would set the height 704, and then we're going to solve it. 40t, so we'll get everything on one side, -16t squared plus 240t minus 704, and I want to know where this equals 0. So I'm going to figure out where it equals 0, but it says where it's above, so maybe I should just say it's going to be a greater than problem. Let's figure out where it hits 704 first. So I got to factor this thing. Well, let's see. I think there's a nice friendly GCF in here. Let's do -16 as my GCF. So then that'll be t squared minus 15t, and then I forgot a t, plus 704 divided by 16 is 44. Okay, so it makes it a lot easier if we do that first. Now to find the numbers that multiply to 44 and add to -15, that'd be 11 and 4. So minus 11t minus 4t plus 44. We'll do the whole split the middle thing. T minus 11 minus 4t minus 11. And you end up with t minus 4 and t minus 11. Now the -16 is part of your factors, but it's not going to affect the zeros. So what happens is at 4 and 11, this thing is hitting 704 feet. So at 4, right there, that's 4, it hits 704. And then at 11, again, right there, 11, it hits 704. So we're finding zeros, but we're finding zeros of a graph that has been shifted down 704 units. We don't have something that helps us solve 704s. We have something that helps us find zeros. So what we kind of do is we imagine that this is sort of the x-axis. We move the whole graph down and say, well, if that was the x-axis, when would it hit? It would hit at 4 and 11. Now, for this problem, we're asked to find where it's above 704. So you can say, well, this is where it hits 704. That's the interval where it's above 704. It doesn't say equals 704. It says strictly above. So I'm going to say this is between 4 and 11, and I'm going to use parentheses because above means not at, but actually above 704. So the interval from 4 to 11 using parentheses is the interval. That's it for our nonlinear inequalities. So probably the next thing you want to do is start working on the crash course. Crash course has everything you need for the test. We'll do some more studying next time I see you, and then we'll take a test. So good luck, and be sure to hit that like and subscribe.